So, today we will be talking about water, pH, and buffers, and basically just all about them. First of all, we're talking about water and its special property and stuff like that can happen to it. So, for example, water has property of cohesion and adhesion. Cohesion is like surface tension. So, water has many hydrogen bonds which keep the H2O molecules together, and those H2O molecules like that are stuck together make it so it's as cohesion, so it like stays together. So for instance, in this cup, sometimes there could be water filled all the way to the top and a little bit over. That's cohesion, like the water's stuck right there until it takes something to break the hydrogen bonds, like more water. And then we have adhesion. Adhesion is capillary action. Capillary action is when water wants to stick to the sides. That's why when you have beakers, you notice how they taught you how to measure that in elementary. They taught you that you need to measure it from the point, like from where it's showing the glass, because in the middle it has like a little divot. It's like it's divot and it goes in like that because water likes to stick. It's very polar and non-polar. It likes to be attracted to stuff. That's why it will go stick. So in trees, for instance, it will start. That's why there's such huge trees in the sky, because water will stick to the sides, and just like because they're very small, the little holes where the water goes, and it'll just keep going up and up and up, stories, hundreds of feet in the air. And also like sweating and boiling points, like the boiling point of water can change depending on the atmosphere and like the pressure and many other things. So if you're higher in the sky, the boiling point will be a lot lower compared to if you're at sea level, which is a lot higher, which is 100 degrees Celsius. And how about pH? pH, there is three different things. There is acidic, basic, and neutral. Acidic is from the pH of 1 to 6. Neutral is 7. And from 8 to 14, that is basic. So let's say like a lime is very acidic. It's an acidity of 2. Bleach is very basic. And those properties are really just about like what they help with, like how like the chemical formation. So as an acid is an H is just a hydrogen bond, hydrogen positive, and a base is a O and an H negative. So basic are very negative, like bleach. And these basic bonds, they love to give, and these acidic bonds love to take and take and take, which is why. So these basic solutions love to give away their O, which is their oxygen, and love to give it to an acid, which is H. So it will make this more basic and this more acidic, and then the goal of like that always happening is to have either a basic, acidic, or neutral solution. And they're different from pH because it's just like the difference from basic and acidity in one container. So right now in this cup, let's say I have an equal number of acid and bases. There will be a neutral solution because it's equal. But if I have more acids in here, let's say I had a bunch of acid, like a lemon, and then one little drop of bleach, it would still be an acidic solution because a lot of acid here. Or if I put a bunch of bleach and like a drop of acid, which is like lemon, it would still be considered a basic solution because it's more base than acidic. And buffers. Buffers are weak acids and weak bases. So let's say your blood. Your blood likes to stay at a slightly alkaline, which is base. Alkaline equals basic solution. Slightly alkaline of like 7.3, 7.4. It likes to stay in between. And it can go either a 1 up, so it can be between 8.4, or a 1 down to a 6.4. But if it goes any higher or lower, we're dead. That's why we have buffers. So let's say you're there eating limes. Your bloodstream will become more acidic. So what happens? Your buffers kick in, and our buffers have like what's called slightly weak bases, and these weak bases will give those acids the O to make them more basic. So that in turn will calm down our pH levels, making us back to neutral. And one buffer that's in like super well needed is biocarbonates, because biocarbonates can can turn an acid all the way to calcium carbonate, which can turn CO2 all the way down to biocarbonate.